Hi, I'm Ashley.
And I'm Jarrett, and this is halogenation, nitration, Friedel Crafts alkylation, and acylation of a benzene ring. Due to the aromaticity present in benzene, it's going to be very difficult to actually get benzene to react. As you'll see throughout this section, preparation of specific reagents is required to break the aromaticity of benzene and add substituents. Halogenation of benzene begins by preparation of a positively charged bromine atom. This preparation is done by reacting Br2 with FeBr3 as seen here. In the reaction, an electron pair from the bromine will attack the iron. This forms a positive charge on the bromine and a negative charge on the iron. In order to deal with this positive charge, an electron pair from this bromine and the bond will come over and attack this bromine here. This yields a positively charged bromine and a negatively charged FeBr4, which can then participate in this reaction above. This is a simple addition reaction, where the pi bond from the benzene ring attacks the positively charged bromine. This leaves a positive charge on the benzene ring, and the aromaticity is now gone. In order to restore the aromaticity, an elimination reaction occurs, where our FeBr4 can now act as a base, grabbing this proton and restoring the aromaticity by restoring the pi bond.
Next, we're going to look at the nitration of a benzene ring. To add a nitro group to a benzene ring, we first have to react the ring with HNO3 and H2SO4. Initially, HNO3 is not a strong enough electrophile to pull electrons away from the stable benzene ring, which is why HNO3 and H2SO4 first have to undergo a reaction with each other, which is shown below. In this reaction, the lone pair on the oxygen here pulls a hydrogen away from one of the alcohol groups on the H2SO4 here. At this point, there is a negative charge on the oxygen where the hydrogen left, and we've successfully formed HSO4-. There's also a positive charge on the oxygen bonded to the nitrogen, which makes this intermediate molecule unstable. So the negative charge on the oxygen here comes back down to reform a double bond and pushes off the water group here. At this point, we've successfully formed NO2+. We then use NO2+ and HSO4- in the nitration reaction above. In the reaction above, the NO2+ is now a strong enough electrophile to pull the electrons from the benzene ring out of this pi bond, forming the bond with the NO2. Then the HSO4 can come in and act as a base, pulling the hydrogen away from the spot where the new bond formed on the benzene ring, which is right here. This pushes electrons back into the benzene ring, restoring the aromaticity of the ring and neutralizing the positive charge left on the carbon in the previous step. And this gives us the nitro group on our benzene ring. Really quick, note that there is a split charge on both the HNO3 as well as the NO2+. This is because nitrogen does not have a low-lying d orbital and cannot expand its octet. In other words, nitrogen can only have 4 bonds.
As always, Friedel Crafts alkylation is going to begin by preparation of reagents. This time we're going to react our alkyl chloride with aluminum trichloride, forming this complex here, with a split charge. This positively charged halogen can then go on to react with the strongly aromatic benzene. A pi bond from the benzene will come and attack the carbon adjacent to the halogen, pushing an electron pair onto the halogen and removing the negative charge. This yields our AlCl4- and our halogen that adds to the benzene ring. Finally, to restore aromaticity, our AlCl4- can act as a base, grabbing this proton and restoring the pi bond, and therefore the aromaticity of the benzene ring in the product. So what if we wanted to add a longer chain to our benzene ring with Friedel Crafts alkylation? Unfortunately, this is not the best method to do so, because with Friedel Crafts alkylation we can get some rearrangements. If we observe the reaction between our alkyl halide and aluminum trichloride, then we see that we get this result down here. However, this result can undergo a hydride shift, also forming the secondary carbocation. So in the end, we'll get our normal product that we would expect, but we'll also get the rearranged product with the propyl group. And since organic chemists want to control everything, so this is not the best reaction for adding long chains onto benzene rings.
Lastly, we're going to take a look at Friedel Crafts acylation. Acylation is just the addition of a ketone to the benzene ring. In order to add a ketone to our benzene ring, we're going to react it with an acid chloride and AlCO3. Like in all of our previous examples, the acid chloride is not initially a strong enough electrophile to pull electrons away from the benzene ring. It first has to undergo a reaction with the AlCO3, where the chlorine attacks the Al, which does not have a full octet, giving an AlCl4- in this structure here. We now have a strong enough electrophile to pull electrons away from the benzene ring. Electrons come from this pi bond and attack the plus charge on this carbon, forming a bond between the two carbons. Next, the AlCl4 comes in as the base, and the negative charge deprotonates this carbon, restoring the aromaticity of the benzene ring, giving us our final product.
Now it's your turn. Try drawing the products for the following reactions. Pause the video, draw them, and then when you're done, check and see if you're right. These are the two products of these reactions. If you got them right, then good job, and if not, then perhaps you should check out the previous portions of the video where the mechanisms were gone over in greater detail. So what have we learned? We've learned that to add anything to a ring, we need a strong electrophile, which often requires preparation. We saw this with the nitration reaction, which proceeded with a sulfuric acid catalyst, as well as with halogenation and with Friedel Crafts alkyl and acylation. Friedel Crafts alkylation can rearrange, and since organic chemists always want to control everything, we need to be careful when adding long chains to benzene rings. In the case that we want to add a long chain, we'll use Friedel Crafts acylation.